In the grand, stratified library of the Earth's crust, every layer is a page, and every fossil is a word, telling a story that spans billions of years. We rely on this chronological order to understand our past. But what happens when a paragraph from the modern industrial age appears seemingly printed in the chapter written 400 million years ago? In 1936, a discovery was made in the arid heart of Texas that threatened to upend the laws of geology. A utilitarian relic, a hammer of forged iron and weathered wood, lay entombed within a block of solid limestone. The rock surrounding it was attributed to the Ordovician period, an era when life was restricted to the primeval oceans long before dinosaurs, let alone humans, walked the earth. For decades, this object, known as the London Hammer, has been wielded as a weapon in the ideological war between evolutionary science and creationism. Is it evidence of a lost advanced civilization, a glitch in the geological matrix, or is there a chemical alchemy at play that can deceive the eye and the radiometric data alike? To understand the truth, we must chip away the stone and examine the cold, hard metallurgy beneath. To truly appreciate the anomaly of the London Hammer, one must first understand the setting of its discovery. The year is 1936. The location is Red Creek, near the small, unassuming community of London, Texas. It is a landscape of dust, heat, and exposed history, where the bones of the earth are often laid bare by relentless erosion. Max and Emma Hahn were reportedly out for a walk along the creek bed when they spotted a piece of loose rock with a peculiar fragment of wood protruding from its core. It wasn't merely sitting on the surface, it was fused within the matrix of the stone itself. Intrigued by this oddity, they transported the rock home. It would sit, largely ignored, a mere curiosity on a shelf for over a decade. It wasn't until 1947 that their son, perhaps driven by the insatiable curiosity of youth, took a chisel to the rock and cracked it open. Inside, perfectly preserved, was the head of a hammer. The revelation was electric. The hammerhead was not rusted away to dust. It remained remarkably intact. The wooden handle, however, had undergone a strange transformation. It appeared to be coalified, transitioning into a coal-like substance, and was partially petrified. But the true shock came from the rock itself. The limestone of the Red Creek area is widely mapped by geologists as belonging to the Lower Cretaceous or even the Ordovician period, depending on the specific strata involved. We are talking about a geological timeline ranging from 100 million to 400 million years ago. If the rock formed around the hammer at the time the sediment was deposited, it implied the tool existed hundreds of millions of years before the first hominids stood upright. This was the chronological dissonance that would eventually catch the eye of Carl Bow in the early 1980s, who purchased the artifact and made it the centerpiece of his Creation Evidence Museum. To Bow and his supporters, this was the smoking gun that dismantled the standard geological column. They argued that for the hammer to be embedded in such ancient rock, the strata itself must have formed rapidly, perhaps during a catastrophic global flood, trapping modern tools alongside ancient fossils. This narrative transformed the London Hammer from a local oddity into a global icon of out-of-place artifacts, or OOPArts. These are objects that challenge the conventional timeline of history: batteries in ancient Baghdad, spark plugs in geodes, and hammers in Ordovician limestone. The allure of such a mystery is undeniable. It appeals to our desire for the unknown, for the possibility that we have fundamentally misunderstood our own origin story. However, a mystery is only a mystery until it is subjected to the rigors of the scientific method. The story of the London Hammer is not just about what was found, but about how it was interpreted. For years, the artifact was shielded from rigorous independent testing, allowing myths to calcify around it just as the limestone had calcified around the iron. Claims circulated that the wooden handle had turned to pure coal, a process supposedly requiring millions of years of pressure. Others whispered that the iron head was forged of a chemically impossible alloy that defied modern metallurgy, immune to oxidation, and created with lost technology. The hammer became a Rorschach test. Where scientists saw a geological curiosity, believers saw a divine intervention. As we delve deeper into the conflict, we must confront the specific claims regarding the hammer's composition. The primary argument against the hammer being a modern tool lies in its preservation. How could an iron hammerhead buried in the ground survive without oxidizing into nothingness? Iron returns to the earth. The proponents of the artifact's ancient origin suggested that the metal was a unique pre-flood alloy created in an atmosphere with different barometric pressures and chemical compositions than our own. They pointed to the lack of rust as proof of its otherworldly or antediluvian quality. Furthermore, the rock itself was cited as irrefutable proof. Limestone, in the conventional understanding, is a sedimentary rock formed by the accumulation of shell, coral, and algal debris over vast epochs in marine environments. If the hammer is inside the limestone, the logic goes, the hammer must be as old as the sediment. However, this perspective relies on a fundamental misunderstanding of how rocks can form. It assumes that all lithification is a slow, linear process spanning millions of years. It ignores the dynamic, often rapid chemical reactions that occur in the Earth's crust every day. This is where the mystery begins to unravel, not through the lens of mythology, but through the lens of geochemistry. The conflict here is between a static view of geology, where rocks are immutable timestamps, and a dynamic view, where the environment is constantly dissolving, precipitating, and cementing materials together. The handle of the hammer provides another layer of complexity. It is not merely wood, it shows signs of coalification. In the popular imagination, coal takes millions of years to form from peat. Therefore, a coalified handle must be ancient. But does nature actually require a stopwatch set to millions of years to turn cellulose into carbon? Or are there chemical shortcuts that can replicate the effects of eons in the span of a human lifetime? The conflict deepens as we prepare to look at the data that finally emerged when the hammer was subjected to genuine scrutiny.
The turning point in the saga of the London Hammer came when the object was finally subjected to independent analysis. The artifact was examined by the Bethel Memorial Laboratory in Columbus, Ohio, a facility renowned for its metallurgical testing. The goal was simple: determine the elemental composition of the hammerhead. If this was indeed an ancient, alien, or pre-flood artifact, the metallurgy should be unlike anything produced in the modern era. The results, however, were strikingly familiar. The testing confirmed that the hammerhead is composed of 96.6% iron, 2.6% chlorine, and 0.74% sulfur. There were no exotic alloys, no unknown elements, and no traces of the high-tech metallurgy one might expect from a lost civilization. Instead, this chemical signature is entirely consistent with 19th century industrial production. Specifically, the iron composition aligns with the Bessemer process or similar steelmaking techniques used widely in the United States during the late 1800s. The presence of chlorine and sulfur is not a sign of ancient atmospheric conditions, but rather impurities often found in the iron of that period, or potentially residues from the surrounding rock leaching into the metal's surface over time. But what of the design? The shape of the hammer is not an enigma. Historical analysis identifies it as a standard American miner's hammer, a style manufactured and sold by the thousands in the late 19th century. The wear patterns on the head suggest it was used, battered, and eventually lost or discarded. The physical evidence points not to a time traveler, but to a miner or a settler in the 1800s, working the harsh Texas terrain, who dropped a tool and moved on. So how do we explain the impossible rock? If the hammer is from the 1800s, how did it end up inside a 400-million-year-old formation? The answer lies in a geological phenomenon known as concretion. Concretion is not the same as the slow sedimentation that creates the bedrock of a continent. It is a localized, hardening process. In the limestone-rich environment of Red Creek, soluble minerals like calcium carbonate are constantly being dissolved by rainwater and groundwater. This mineral-rich water can surround a foreign object, like a hammer dropped in a crevice or a mud puddle. Over time, the water evaporates or chemical conditions change, causing the minerals to precipitate out of the solution. They harden, cementing the surrounding sediment into a solid, rock-like mass around the object. This process does not take millions of years. Under the right conditions, a concretion can form in decades, or roughly a century. The London hammer was not embedded in the original Ordovician bedrock. It was encased in a concretion that formed on top or within a crevice of that bedrock. The hammer was likely dropped by a worker in the late 19th century. It fell into a depression in the limestone where it was covered by mud and mineral-laden water. Over the next 50 years, the minerals hardened around it, creating the nodule that Max and Emma Hahn found in 1936. As for the handle, the process of coalification, the conversion of organic matter into coal, can indeed occur rapidly. It is not strictly a function of time, but of chemistry, pressure, and temperature. In a sealed, oxygen-deprived concretion, the wood could easily undergo accelerated carbonization,
giving it the appearance of ancient coal without requiring the passage of epochs. The London hammer serves as a powerful testament to the complexity of the natural world and the human desire to find wonder in the mundane. It is a case study in context. When we remove an object from its geological context and ignore the specific chemical processes of the local environment, we open the door to wild speculation. But when we apply the disciplined lens of metallurgy and geochemistry, the impossible becomes explicable. The hammer is real. The rock is real. But the timeline connecting them is a product of natural cementation, not temporal anomaly. The scientific consensus is clear. This is a post-settlement tool, a relic of American industrial history, preserved by a quirk of Texas geology. In the end, the London hammer tells us less about the deep history of the Earth and more about the recent history of the American frontier. It is a snapshot of a moment in the late 1800s, frozen in time by the rapid action of mineral-rich waters. It reminds us that the Earth is an active, dynamic laboratory. It does not stop building, hardening, and transforming just because the geological eras have been named and categorized. Concretions continue to form today, encasing soda cans and car parts in rock that future generations might one day mistake for ancient artifacts. The London hammer is not a deception, but a misunderstanding, a collision between human timescales and geological processes. As we close the file on the London hammer, we are left with a renewed respect for the investigative process. It is easy to look at an anomaly and declare it a miracle. It is much harder and much more rewarding to do the work of testing, analyzing, and understanding the mechanisms at play. The hammer remains a fascinating object, not because it breaks the laws of physics, but because it demonstrates them so beautifully. It shows us how quickly the Earth can reclaim what we leave behind, turning our steel and wood into stone and coal, folding our fleeting presence into the long, enduring narrative of the planet. The impossible hammer is, in fact, entirely possible. It is simply a miner's lost tool caught in a geological embrace, waiting for science to set it free.